Okay, limits with infinity. We've got 3 points on the front of the notes booklet that we want to discuss. The limit as x approaches infinity of the function f of x is equal to a. That tells us that there's a horizontal asymptote at y equals a. When the limit as x approaches b of the function f is headed to positive or negative infinity, that limit does not exist, but we indicate the direction that the function is headed as it approaches b as either up toward positive infinity or down toward negative infinity, and that tells us that there's a vertical asymptote at x equals b. And when we're thinking about horizontal asymptotes, looking at their equations, we're going to use the acronym BOBO, BOTN, EATS, DC to recall how to find the end behavior of a rational function, which would be its horizontal asymptote. And we'll review what that acronym means when we get to it in example 2. First, let's take a look at example 1, which asks us to find the limits with infinity graphically. First, we're going to list all of the vertical asymptotes that we see on the graph of this rational function. And here's one at y equals 0, and another at x equals 0 and x equals 3. Those are the vertical asymptotes on the graph. And then horizontal asymptote shapes the end behavior on the left and the right sides, and we can see that's occurring at 1. And that would be y equals 1. So let's evaluate each limit statement. In A, the limit as x approaches 4 of the function f. This is a two-sided limit since there's no superscript after the 4. So we're coming from the left side toward 4 and the right side toward 4. From the left, we're approaching 0. From the right, we're also approaching 0. So the limit as x approaches 4 is equal to 0. Okay, in B, we're approaching 0 from the left side, so starting at negative infinity, we're coming along the function, and as we approach 0 from the left, the curve is headed down to negative infinity. That limit strictly does not exist, but we indicate the direction that the curve is heading with the negative infinity notation. C, now we're approaching 0 from the right side, and that's this part of the graph in the middle. As we approach 0, the curve is headed up to positive infinity. Okay, in D, we want to approach the limit as x approaches 1 from both the left and the right, and that is going to exist and equal 3. From the left side, we're approaching 3. From the right side, we're approaching 3. Okay, E, the limit as x approaches positive 3 from the left side. So we're coming from negative infinity towards 3, and we can see the curve is headed up to positive infinity along that vertical asymptote at 3. Then the limit from the right side, so we're starting at positive infinity, heading towards positive 3, and the curve is going down to negative infinity along that vertical asymptote. In G, the limit as x approaches negative infinity. So we're headed towards the left side, towards negative infinity, and we're looking at the end behavior of this curve, and we see it's coming up, but it's not going up to positive infinity because it can't cross this horizontal asymptote. So it's getting closer and closer and closer and closer to y equals 1. That limit does exist at the vertical asymptote, so the limit is 1. As we head to the right side, as x approaches positive infinity, the same horizontal asymptote is impacting that end behavior, so that limit also exists and is approaching 1. Then the limit as x approaches negative 1 from both the left and the right, that's going to equal 0. Coming from the left is going to 0, coming from the right is going to 0.